Hello, I'm going to take you through what we call classless subnetting, classless subnetting. So before we jump to classless, we have two. We have what you call classful and then classless subnetting. So with classful, you have your network maybe .0/24, which is 255.255.255, then .0, meaning that if I want to know the number of IP addresses, IP addresses are supported by this subnet mask. Here we have 8 ones, 8 ones, 8 ones, and then here 8 zeros. So it will be 2 power 8, and this is 256. So let's assume that I want to subnet this network here into 4 equal subnets. 4. So already we know the subnets that there are 4. So automatically, using the other formula, which is 2 power x, these are borrowed bits. Borrowed bits. So the number of subnets, we know that we need 4. Then going to 2 power x. 2 power x, so we introduce powers, and then it will be 2 power 2, then 2 x. This crosses with this, and then we remain with x is equal to 2 bits. Then you can answer all the other questions that I mentioned so far, because now here the network has changed so far, because this is what we had actually in this, the parent address. We have 256 IP address. Now, with these 256 IP addresses, we need them. We need these IP addresses grouped into 4 subnets. And our subnets, they are here into 4 subnets, and each subnet here, it's going to have actually now this time we need the other formula, number of usable IP addresses equal to 2 power p. Now this minus 2, but p here represents the host bits. So now to get actually on the right track here, since we managed to get the bold bits, because our network this time it's 168, then 1.0, it's no longer /24, because the /24, it supports this one here, it's the one that supports 256. But now these 256, we are supposed to group them into 4 groups. And our new subnet, now this time we said there are 8 bits here, subnet mask. And then 8, then this other octant, the bold bits already, we got the bold bits. Our bold bits are here. They are these ones. These are our bold bits. So this time we're going to have 2. 1, 2, then the rest of it, the 6, are going to be the hosts. So these are hosts, and then these are bold bits. But still, the bold bits are part of the network. Bits. So with this one here, it will actually give us because from here we know the number, the bold bits, the host bits, and then the magic number. Our magic number is going to be 2 power this, the host bits. I can use M, the host bits in an octant boundary. Boundary. So it is 2 power this. The host bits in an octant boundary, they are 6, giving us 64. So the 64, as you can see, it's going to be uniform for all. Our first network, it will be 192.168.1.0. So if I want the second subnet or the second group, I will add 64. And then it becomes 192.168.1.64. If I want the other next one to be 192.168.1.128. Then lastly, it will be 192.168.1, then dot 192. So these are 4 subnets, 1, 2, 3, 4, of the same size, the same size, same size. So that's the reason why we call this method as classful, because the subnets, all of them, they are of the same size. They have the same size. So today, mostly or mainly, I want to tackle the what we call classless, classless subnetting. What you call uh, uh, what we call with classless subnetting, still you can code it what we call or you can code it VLSM, which stands for variable length. It's variable length subnet mask, which a mask. So this is VLSM. So this is what I'm going to work on. So last time I remember, last time we had an exercise, and this each we had something like slash, okay, 400. Okay, I'll leave this and then give you the other one as the exercise. Okay, that if I have maybe the total number of addresses of 100 uh, hosts, maybe, okay, 100 hosts. Oh, okay, 20 and then 100 hosts. 20 and then 100 hosts. So I have this network address the same, which is 168.1.0/24 as of now. So I need a subnet that supports 2 groups here, 2 subnets that supports these 2 groups of hosts. So what I'm going to do is just to rearrange. You rearrange the number. You start with okay, in descending order. You start with the biggest and end with the lowest or the smallest. So I have 100 and then 200. So as I'm trying to get to the subnet that supports these 2 groups, I will first get to the one that supports this, the biggest number, and then go to this other number. So with this, of course, I will have to we have our 100 here. Okay, the 100, if I divide it by 2, of course, I will get 50, and then remainder 0. by 2, I'll get 25. Get 0 by 2, I'll get 12. Remainder 1. By 2, I'll get 6. Remainder 0. By 2, I'll get 3. Then remainder 0. By 2, I will get 1. Remainder 1. Yeah, so this is all I need in 100. So I will have 1, just 1, 1, then 2 zeros, then 1, then 2 zeros. So the reason why I'm actually 1, 2, 3, 4, 5, 6, 7. So the reason why we're converting here is just to get to know the number of bits that are in 100. So since there are 7, I'll just go back to my subnet mask, which is 255, 255, 255.0. So when it comes to binary number, then of course I have 8 ones here, 8 ones, 8 ones. 8 ones. Then, since these are 7, it means there will be 8 zeros, and then the other one will be 1. So I will have a 1 here, then 7, these are 4, like this. So once you have this, then automatically you will be able to get the subnet mask and then the range of the IP address, the group of IP address that you need, because this is our address. So how many IP addresses do we need from this starting point? Now we can use the other formulas. The number of subnets. If I'm to use this subnet, because our subnet it will be 255 this time, 255, then 255. 255, then dot 128. So if I'm to use this subnet, how many groups will I get? So number of subnets is equal to 2 power bold bits, which is 1, and it gives us 2. So the subnets, there will be 2. Then how about the usable addresses? Let me use IPs. It will be 2 power host bits, which are these. 2 power 7 giving us 128. So there will be 2 groups, 2 subnets. Each subnet it will actually have actually support 128 IP address. Then how about the magic number? So the magic number is going to 2 power the host bits in an octant boundary, still there are 7. So our magic number is 128. So I'll just come here and try to list the address. It will be 192.168.1.0. The next subnet here, I will use the magic number, add it here. So it will be 192.168.1. Plus this, it's 128. 128. Remember here, we need only one subnet, but I've listed 2 of them. But I will just try to come up with, okay, the one. So here, the first usable IP address, you add the 192.168.1.1. This is the first. Then the last usable IP address, I can actually skip and first subtract the 1 here. And it will be 192.168.1. If I subtract the 1, it will be 127. Then subtract the 1 there. 192.168.1.126. So we wanted only one subnet that supports 100. So it is here. When you look at the number of IP addresses that we need, there are 100. But this one here, the range, it exceeds up to 127, meaning that it supports this range, it supports 100. So here, yes, we have this subnet here, and we're done. But we have other IP addresses starting from 128 and then that are beyond. Those IP addresses, they are free and they are available. They are available. So what you're going to do, this one here, it is again available for us to group again. Now, remember we have the other group of address, 20. So still I will use the other method. We have our 20 here. By 2, I'll get 10, remainder 0. By 2, get 5, remainder 0 still. By 2, I'll get 2, remainder 1. By 2, I'll get 1, remainder 0. So I need this up to this. So it will be 1, 0, 1, 0, 0. But please, we can actually prove, because this is power 0, 1, 2, 3, then 4. So this one here, it gives us 16, and then this one here, it gives us 4, totaling to 20. So we're on the right track. So the reason why we do this is just to get to know how many bits are within this total number of hosts. So far it's 1, 0, 1, then 2 zeros. How many are there? 1, 2, 3, 4, 5. There are 5. So this time I'll go back and add. Remember what we had? It was 8 ones, 8 ones, 8 ones, and then 1, 7 zeros. Therefore, then more 3. Now this time we are saying that the subnet mask that supports 20, the host bits are supposed to be 1, 2, 3, 4, 5. So I will come again here and make sure that I have 5 zeros. 1, 2, 3, 4, 5. Then the rest are going to be ones. In other words, it will be this way. 8, 8, and then 1, 3 ones, and then 5 zeros. See? And then we again redo the previous, we use the previous formulas. Number of subnets, if I'm to use this formula here, if I'm to use this formula, number of subnets with 2 power bold bits. The bold bits here we have 3, giving us 8. That with this formula, it supports 8 groups. Or we'll be able to get 8 groups. See? And then the usable IPs, 2 power host bits. The host bits are 5, giving actually minus 2, giving us 120. Sorry, not 120, but 32. You subtract 2, get 30. So each group, it has to support 30 usable IP address. Then the magic number is equal to 2 power host bits in an octant boundary. Still there are 5, giving us 32. So here I can actually try to list the subnets. But now if I'm to list the subnets, of course I have to start from the previous one, because from 1 up to 192.168.1.0 up to 192.168.1.127, this range is used. Now what is available, it's 192.168.1.118 128. So this is where we are supposed to start from, and still we need one subnet, and then we add the range, the range, because they're saying per group, per group it will have to have 32. So if I'm to get the next subnet, I would add the magic number that I got here, which is this one here. It is a 32. So I will come and add it on this and then get 192.168.1. If I add 32 here, of course it will be 160. 160. So the first usable IP address here, it will be 192.168.1. If I will add 1 here, dot 129. And then the last usable, if I subtract the 1, I will remain with 59. If I subtract 1, then automatically I will get 192.168.158. Then here 192.168.159, like that. So this is another group, because this one here, it's the one that supports 20. And then the previous one, the one that we got here, where on this, as you can see, this range, it's the one that supports 100. So that is how you keep, actually how you keep adding. You group this, you group, because we had 100. So its range, it was from 192.168.1.0 up to 192.168, then .1.127. Now another group it started from is for 100. Then for 20, of course, we have to start from this. It has to be continuous. 192.168.1.128 up to 192.168.1.16, not 160, but 150. So when you look at the range has changed, and even the subnet mask. The subnet mask for this one here, it is slash 25. And then this one here, it is slash 24 plus the other one, it's 27. It's 27. So the subnet mask here, it will be 255, then 255, 255, then 224. But the other one in the first place, the subnet mask, it was 120, 28. Okay, so I'll just give the exercise here. Use this network address 192.168.100.0/24. Divide or subnet this network to support 40, then 40, and then 110, and then 9 hosts. So at the end, you will actually get 3 subnets, but of different size. Of different size. In other words, you will have 3 ranges. One for 40, another one for 110, another one for 9. But remember, you have to first organize this. You organize this and make sure you start with the biggest, and then we have 40, and then 9, like this. So you keep using this method that we have used. Yeah, so that is it.